Friends, welcome to my channel Clinical Biochemistry by Dr. P.K. Prabhakar. Today we are going to talk about another inborn neurometabolic disorders of amino acid metabolism, and that is alkaptonuria. What is alkaptonuria? Something I have some basics I have told you in my previous lectures, but again we are going to talk about in the details. This alkaptonuria is similar to phenylketonuria. This is also a metabolic disorder of the phenylalanine and tyrosine amino acid metabolic process. So, in the previous video we have discussed about phenylketonuria, where phenylalanine was converted to the tyrosine. Phenylalanine is an essential amino acid, tyrosine is a non-essential amino acid, and if you see phenylalanine and tyrosine both are glucogenic and ketogenic amino acids. And the basic usage of phenylalanine and tyrosine in our body is it gives you different kind of hormones, like it gives you epinephrine, it gives you norepinephrine, it gives us different color pigments like different kind of melanins, it gives us different other metabolites. So, that is the use of phenylalanine and tyrosine. Out of these things, phenylalanine does not have too many of uses. Phenylalanine is having only two important functions in our body. First function is phenylalanine is participate in the protein synthesis, and second important function of phenylalanine is it has to convert it to the tyrosine. So, this is second most important function other than the protein synthesis synthetic functions. So, this tyrosine is now then converted into different metabolic process. In the previous video also I have told you this both phenylalanine and tyrosine is glucogenic and ketogenic in the nature, because it gives you glucose as well as the ketone body. So, that also we will see how it is going to be converted. So, this is the pathway how this is going to be metabolized normally. So, this is we will see this metabolic process, and then we will talk about alkaptonuria. So, first this phenylalanine, as yesterday in my previous lecture we have seen it, this phenylalanine is converted to tyrosine by a specific enzyme that is called as phenylalanine hydroxylase. This in short form in abbreviation we are going to call PAH. This PAH is going to be converted, this requires tetrahydrobiopterin, remember that one. So, that I will put it in that phenylketonuria video in the description box. So, you can see, if you not watched it you can see it. So, this once we have got tyrosine, this tyrosine is converted to para-hydroxy phenyl pyruvate. This is a keto acid. So, this tyrosine conversion to para-hydroxy phenyl pyruvate by a specific enzyme that is called as transaminase enzyme. This is a transamination reactions. So, here we require alpha ketoglutarate and glutamate will be the product. So, the tyrosine and alpha ketoglutarate, this is amino acid and the keto acid is alpha ketoglutarate, both reacts, and ultimately this will be converted to the keto acids, and alpha ketoglutarate will be converted to glutamate, like it will be like this one. So, we are having alpha ketoglutarate as a keto acid and it will be give you glutamate. So, this is a transamination reactions, and every transamination reactions normally requires PLP as a cofactor, that already we have seen in the transamination video. Then this para-hydroxy phenyl pyruvate is converted to homogentic acid. This homogentic or homogentic acid conversion is done by the enzymes which works on this para-hydroxy phenyl pyruvate. The enzyme's name is para-hydroxy phenyl pyruvate dioxygenase. This enzymes is a copper containing enzymes. So, this enzymes requires copper as a cofactor, plus it also requires vitamin C. The two most important feature of this reaction is, this conversion reaction is, here we are having decarboxylation also plus hydroxylation also, means water as well as carbon dioxide is going to exit from this pathway. So, here we are having removal of carbon dioxide plus water. So, that is important feature. Now, this homogentic acid will go for further metabolize further process, where it gives us 4-malloacetoacetate by a enzyme. This is called homogentic acid oxidase. This homogentic oxidase we are also calling homogentic oxidase or homogentic acid oxidase. This is iron containing enzyme. So, this enzymes requires oxygen here and converted to 4-malloacetoacetate. This 4-malloyl acetoacetate is isomerized and gives us 4-fumaryl acetoacetate by a isomerase enzyme. and this 4-fumarate acetoacetate is going to be hydrolyzed, degraded, divided into two different fragments. One fragment is fumarate, other fragment is acetoacetate by a specific enzymes, that is called as fumaryl acetoacetate hydrolase. So, this is hydrolase, means with the involvement of water it is going to be lyzed into two fragment, fumarate and acetoacetate. The fate of this fumarate, it is a one of the intermediate of Krebs cycle, citric acid cycle. So, either it will go to the TCA cycle for further metabolic process metabolized, or it will give me glucose through via gluconeogenesis process. So, fumarate is a substrate for gluconeogenesis also. So, by this fumarate gives me glucose. So, phenylalanine and tyrosine, by this process it works as a glucogenic amino acid. Now, this acetoacetate is a substrate which works as the 3-carbon compound for this formation of different odd chain fatty acids. So, there it gives me fatty acid. So, here it is ketogenic. So, initially I have told you phenylalanine and tyrosine works as both glucogenic and ketogenic amino acid. So, this is how it is will be working as glucogenic and ketogenic. Now, this is the whole metabolic process. So, we require 1, 2, 3, 4, 5, 6 enzymes. So, this 6 enzymes roughly gives, means all enzymes are going to give me different kind of inborn neurometabolic diseases. So, we are having 5 different kind of inborn neurometabolic disorders by blocking every enzymes. So, we will say one by one. So, if this enzyme will be blocked, we will have phenylketonuria. So, this is the disease which we have already discussed. So, if this phenylalanine hydroxylase will be blocked, we are having defective phenylalanine hydroxylase, we will have phenylketonuria disorders. If this tyrosine transaminase enzymes will be blocked, we will have tyrosinemia type 2 disorders. So, if this will be blocked, we will have tyrosinemia type 2 disorders. If we are having this para-hydroxyphenylpyruvate dioxygenase deficiency, or it will be means defective, it will cause us, it will gives us neonatal tyrosinemia. So, this blockage gives me neonatal tyrosinemia. So, first phenylalanine hydroxylase, phenylketonuria, means tyrosine transaminase, tyrosinemia type 2, para-hydroxyphenylpyruvate or dioxygenase gives me neonatal tyrosinemia. Now, homogentisate acid oxidase, if this enzyme will be blocked, we will have a very important disease, that is called as L-captonuria. So, this L-captonuria is going to be caused because of the defective homogentisate oxidase, which we are going to see today. We are going to see now. If this enzyme or this enzyme will be blocked, we will have a same disease. That disease we are going to call tyrosinosis. So, this one and this one leads to tyrosinosis, or we are going to call tyrosinemia type 1. Tyrosinemia type 1. So, these are the 5 different metabolic disorders which we are going to have by different defective genes. So, if gene for phenylalanine hydroxylase deficiency abnormality cause phenylketonuria, defect in the tyrosine transaminase causes tyrosinemia type 2, defect in the para-hydroxyphenylpyruvate dehydrogenase, this causes neonatal tyrosinemia, defect in homogentisate acid oxidase causes L-captonuria, defect of mallyl acetoacetate isomerase or fumaryl acetoacetate hydroxylase. This too leads to either tyrosinosis or tyrosinemia type 1. Now, so we are not going to say all the diseases now, we will say only L-captonuria. So, just for a second. Now, if this enzyme homogentisate oxidase is going to be blocked here, so what will happen? We are unable to use homogentisic acid. So, in this case, homogentisic acid is going to be accumulated in our body. Now, this accumulation of homogentisic acid ultimately leads us different kind of disorder, different kind of abnormality, different kind of features. So, that we will see. Now, some of the important feature of this L-captonuria disorder is this L-captonuria is one of the first metabolic disorders, first inborn metabolic disorders which was studied. It is not only the first characterized inborn metabolic disorders, but first ever disease which is identified, which is that will be inherited, means the first inherited disorder which is studied is L-captonuria only. So, this is first inherited disease which was studied as inherited, that is L-captonuria. This is the first inborn metabolic disorders which is studied, that is L-captonuria. So, on the basis of this one only, Garrod has studied, Garrod had given the term inborn metabolic disorder. So, this is the almost oldest or the first ever inborn metabolic disorders. Now, how this is going to cause, how this homogentic acid accumulations leads to abnormality. So, there are three different kind of abnormality. The accumulation of homogentic acid leads to three different kind of abnormality in our body. So, first it is going to cause homogentic aciduria. First disorder is called as homogentic aciduria. So, this is because of homogentic acid accumulations. Second one is large joint arthritis. Second one is large joint arthritis. It is slightly different from the rheumatoid arthritis. And third is black ochronotic pigmentation of cartilage of ochronotic pigmentation of cartilage and connective tissue. So, we will see one by one how this is going to happen. First, we are having, because of this disease is caused because of the defect of homogentic acid oxidase. Homogentic acid oxidase. So, because of this one, we are having accumulation of homogentic acid in our body. So, this homogentic acid or homogenticate is going to be accumulated in our body. So, the first this accumulated homogentic acid is going to be converted into quinone derivative, that is called as benzoquinone acetate by, it is converted to benzoquinone acetate, and then this benzoquinone acetate is converted into, it is going to be polymerized, it will be multiple units of this benzoquinone derivatives is going to be polymerized and gives you a black color pigment, that is called as L-captone. This is called as L-captone. This L-captone binds to different tissue, it binds to especially soft tissue of our body. So, this is the main product which is going to cause defect. In this case, this is polymerization reactions. So, this is polymerization, and at this step we require a specific enzyme that is called as polyphenol oxidase. Here we require a specific enzyme that is called as polyphenol oxidase. Now, we will see how these three different kind of abnormality is going to leads to three different kind of disorders occurs because of this process. This is the diverted pathway. Normally, you do not have metabolic process because tyrosine is not metabolized up to fumarate or acetoacetate because homogentic acid oxidase blocking. So, once this will not be occurring, then this homogentic acid will be accumulated and it will be diverted to other metabolic pathway. So, other metabolic pathways, one of the metabolic pathway is this one, where it converted into L-captone, which is a polymeric product. Now, we will see how this is going to happen. First, homogentic aciduria. Aciduria means urine will be, because we are talking about urea. So, it means we are talking about the urine. So, urine will be acidic. Why? Because of presence of homogentic acid. when body is having too much amount of homogenetic acid accumulation, this will be excreted into the urine, and because of this acid presence into the urine, urine will be acidic. So, here it is acidic urine because of the presence of homogenetic acid. So, it is called as homogenetic aciduria. So, that is one of the things which is caused because of homogenetic acid in the urine presence. Now, second one is large joint arthritis. This is a solid substance. So, this L-capton is a black solid substance, it can be precipitated. So, if this is going to be deposited between the joints, between the soft tissue, between the different connective tissue, I have told you it will connect joints between the vertebra, different kind of joints, different connective tissue, different vertebra. So, that word we are if it is going to be deposited between the joints, between the vertebra, between the soft tissue, nose, ears, ear pinna. So, then we are going to call ochronotic, ochronosis. The disease form is called as ochronosis. When this is going to deposited between the joints, it is called as arthritis. So, the arthritis is the friction between the bones when it will be reduced because of the replacement of hyaluronic acid between the joints, it is called as arthritis. So, here it is replaced by L-capton. So, hyaluronic acid is going to be replaced by L-capton. So, joints is having more friction. So, it is a similar type of arthritis type of activity. So, this is called as large joint arthritis, which is because of the deposition of L-capton between the joints. And third is this color of this compound is black. So, this black color compound is going to be deposited between the soft tissue and the cartilage like ear pinna, nose, different other cartilages substances. So, because of that one, the place where it will be deposited, it will looks like black. So, that is called as black ochronotic pigmentation of connective tissue and the soft tissue. Now, how to find out? Because this disease is not a very serious disease. So, normally we do not have very diagnostic tools we are having, techniques we are having, but whenever this a person who is having this enzymes deficiency or they do not have this enzyme deficiency, means they are having homogenetic acid in their urine. So, if this urine will be left out into the air for longer duration of time. So, if the person who is having this disease, if their urine will be left out into the air, so it will be oxidized and it will give me L-capton. So, urine becomes black urine. So, urine is going to be black, and so that is why this L-captonuria is also called as black urine disease. So, urine is going to be converted into black color, looks like coke. So, the urine looks like coke. So, that is why it is called as black urine disorders, black urine diseases. So, many L-captonuric patients suffer from arthritis because of the deposition between the joints, and especially if it going to be deposited into the soft tissue, that portion is going to be looks like black. Now, because of homogenetic acid works as a strong reducing agent, this homogenetic acid works as a strong reducing agent. So, if you want to identify, you can identify them by the reducing test, but the drawback is if you are going to test urine for the reducing agent as a reducing means for the reducing compounds. So, there are number of other reducing agent is also present in the urine like sugars. So, any other reducing compound like glucose, fructose or any other sugars or any other compound will be there in the urine, that will give you false positive result. So, it is a drawback. Otherwise, this can be identified to semi you can call it confirmatory test, that is called as ferric chloride test. One is ferric chloride test. This test we have already seen in case of phenylketonuria. There we have two tests, one was Guthrie test, other one was ferric chloride test. Guthrie test was by using the bacterial strains, that was Bacillus subtilis, and second one was ferric chloride test. This was a non-confirmatory test. Similarly, here also it is a non-confirmatory test. The second test we can do for this one is that is also non-confirmatory test, that is called as silver nitrate test. So, second test we can do silver nitrate test. So, these are the two partially you can call it semi-confirmatory test. Now, how to treat this patient, a person who is having alkaptonuria, how to treat them? We do not have any kind of management strategy or we do not have any medicines. The only thing is you have to give person a phenylalanine tyrosine restricted diet, means his diet should not contain too much amount of phenylalanine, too much amount of tyrosine. So, the person should avoid any food, any diet which contains phenylalanine tyrosine. So, this is all about alkaptonuria. Hope you have understand it. If you have any query, any comments, you can write in the comment box. If you have not subscribed my channel, please subscribe it. So, thank you very much. Have a nice day.